Right. If you can hear me, please put your name in the chat. If you're in the chat and you can hear me, please put your name in the chat so I can know. Okay, I see you, Michelle. Who else? If you're present, please put your name in the chat. Just put your name in the chat so that I can know who's present. Joanne, are you present? Tamaka, Antonisha, are you present? I just want to know those who are present. If you're present, please put your names in the chat. Okay. I don't know why some are not putting their names, or you can say hi or something. Say something so I know who's present. Alex, are you present? Invi, are you present? Right. Well, I'm just forced to start either way. Right. So, first of all, we talked about the main features of volcanoes, the things that you find on volcanoes. Here we are starting with earthquakes. We'll talk about their main features. So, you move with the two of them together, the volcanoes and the earthquakes, the volcanoes and the earthquakes. Remember that this is your geo, which is three themes, right? You have three themes in geography, and once you're done with them, you're done. So, geography, IGCSE, geography. IGCSE geography. Remember the themes that you have only three themes. So we are at the center one. There's theme one, okay, which is population and settlement. So population and settlement. This is the very first theme. Then we are at the second theme. So population and settlement is the very first one. We are at theme two. Theme two, which is the natural environment. Okay, that's the second. Oh, hi, I can see you with the natural environment. This is the second theme. The natural environment is the second theme. Theme one is population and settlement. Theme two is the natural environment. Then we have theme three, theme three, which we're not talking about right now, but you should just know that generally your geography is broken into three themes. Okay, is broken into three themes, and theme three is called economic development. And when we're done with this, the next thing we'll do is map reading and these other things, just to make you be good at the other papers. We are looking at the natural environment. In the natural environment, we'll talk about earthquakes and volcanoes. Then we'll talk about rivers and coasts. Then we'll talk about weather. Then we'll talk about climate. So it's like we have what? Four things. Four things to talk about. Okay? Earthquakes and volcanoes, rivers and coasts. Then we'll talk about climate. Then we'll talk about weather. And those are separate things. So we're starting with earthquakes and volcanoes. I kind of talked about a lot of things about volcanoes. So when you're doing this topic, earthquakes and volcanoes, it's in theme two. We are in theme two. Out of three, we are in theme two, which we said theme two has earthquakes and volcanoes. Okay? Earthquakes and volcanoes. Don't ever forget this. Then you have rivers and coasts. Rivers and coasts. Then you've got weather and climate. You can say you've got climate. Then you're going to have weather. Okay? Then this is going to be the natural environment. Okay? If you're done with this, then I can say you're done. So climate, it's climate and vegetation, or natural vegetation. Then you have weather. So these are the four things you should know from this theme. And we are on earthquakes and volcanoes, this topic. And when you do this topic, so things keep going deeper and deeper, right? You start at theme two, and these are the topics from theme two. Then subtopics now, the parts that you should know. Okay? We are doing earthquakes and volcanoes. What should I know in earthquakes and volcanoes? What should I know? For me to say I'm done, you should know their main features. Okay? You should know the main features, the things that you find on both. Okay? The things that you find on both earthquakes and volcanoes. You should know what is an ash cloud. Ash cloud. I talked about a lot of things about when we talked about volcanoes. A lot of things that you must know. What is lahars? What's pyroclastic flow? What is a volcanic bomb? It's not too hard. Okay, it's not too hard. You need to know these definitions. I'll get back to them later. But these are features that you find on a volcano. Then what about the main features of an earthquake? What are the things that you find on an earthquake? When you know them, then you talk about the distribution. What earth do we find them? Then you talk about the causes of earthquakes and volcanoes. What are the things that can cause earthquakes and what are the things that can cause volcanoes? Then their effects, and also now when we talk about their causes and their effects, we'll talk about how to reduce their impacts. Okay, reducing the impact. And you'll be done with this topic of earthquakes and volcanoes. Then we'll talk about rivers and coasts. We'll see how to do it. So right now we just want to talk about the main features of earthquakes, and we'll get to distribution of both earthquakes and of volcanoes. So let's talk about it. Earthquakes, right? We introduced volcanoes to you, and I did that. Now we are on earthquakes. What are the main features of earthquakes, right? We want to talk about it. We are introducing you to this. Then we'll start to look where both earthquakes and volcanoes are found, their distribution. It means where they are found. Then their causes, what causes them. So there we go. Now, what am I going to do? Earthquakes can, let's start. What is an earthquake? We start from there. What is an earthquake? So I kind of said it when we're talking about volcanoes. Write with me. An earthquake is just a sudden, violent shaking of the ground. It's just a sudden, violent shaking of the ground. Just a sudden and violent shaking of the ground. Okay? Earthquakes, or you can say tremors. It's a sudden violent shaking or tremors on the ground. Okay? Earthquakes are caused by pressure that builds up when tectonic, we'll talk about them, don't worry, when tectonic plates move. Earthquakes are caused by pressure that builds up when tectonic plates move. When tectonic plates move, there's going to be pressure that builds up, and when that pressure is released, it's an earthquake. It's a tremor. Okay? So now let's put a diagram so that you then see what then happens and everything. So here is going to be, you have the ground here. You're going to have this as the ground. Okay, this is going to be the ground. And when you have the ground, here you're going to have a house. Here you're going to have a nice triple story mansion of yours or whatever, you know. I'm not good at art, but here's a nice house. Here's a nice beautiful house. Now, in your nice beautiful house, this is the ground. This is the ground level. So we can say this is the ground level or the surface. Here you have the surface. Then now if you go underground, this is what happens now. You have your buildings, and now if you go underground, there is going to be what? Here, when you go underground, you go deep, you're going to go and find out, if you go find, let me put a point. We want to find out where the earthquake will originate and how it will go all the way up, right? So the earthquake will originate somewhere down here, right? The earthquake will originate somewhere down here. This is where it originates. And if you go straight up to meet the point on the surface where it is directly above where the earthquake originates, that point we'll call it epicenter. So epicenter is going to be the point on the earth, which is just above where the earthquake will originate. Are we together? So you should know, we'll talk about it. Remember that we're going to talk about the features, main things that you see on an earthquake. Okay? Everybody needs to know the features. What are the main things that you're going to see on an earthquake? Then after we talk about them, here at the place on the bottom here, you can call it the focus. It's called the focus. Then right above it, we're going to call it the epicenter. Then after that, you start to show that, okay, so my earthquake was going to spread out. So of course it's going to spread out everywhere like that, going all the way like that. This is where the earthquake starts at the focus, and it spreads out everywhere, radially like that. Radially. Yes, Alex, I see you. Welcome. It spreads out radially like that. So this is the spreading out of your earthquake. It spreads out radially. Okay, you must be able to put that. So this is going to be the focus where the earthquake starts. Then you're going to have the epicenter, which is a point on the surface that is directly above the focus, directly above where the earthquake starts, right? Then what you're going to have, the crack, call it the fault here. You can put it whatever way you want to put it. These ones are the seismic waves, the waves that are caused by the earthquake, the tremors. Okay? Then this is going to be the fault. So now we'll need to talk about these. We will now need to talk about these points. Let's quickly put it. So now let's write features. Features of an earthquake. They are there in the diagram above. We're just going to write them below here to say what are they. Okay, but it's so easy. Everybody can see, everybody understands them. So easy, right? Let's just write about them. So number one, what is the most important thing? Focus. So what is the focus? This is the point. This is the point below the Earth's surface. Below the Earth's surface, at which the earthquake starts. The earthquake starts. There's violent shaking which is caused by these plates, these tectonic plates moving. Okay? Then next we put epicenter. What will be now the epicenter? It is the point. It is the point on the Earth's. The point on the Earth's surface that is directly above the focus. Focus is where the earthquake starts. Hey, come on. Okay? Number three, magnitude of the earthquake. What do we mean when we say the magnitude of an earthquake? This refers to the amount of energy released by earthquakes. So magnitude of the earthquake is the amount of energy it releases alone. Then number four, we keep going, okay? Moment, magnitude, scale. This measures the magnitude of the scale. Magnitude of the earthquake. It measures the magnitude of the earthquake. Okay? Then the fifth and final thing is a Mercalli scale. This just measures the amount of damage. This one just measures the amount of damage caused by an earthquake. Oh, so this is all we gotta know. Yes, when it comes to features, yes. This is what you gotta know when it comes to features. You just need to know these parts of an earthquake. Okay? You just need to know these parts of an earthquake. Give me a second. Okay, that's a good question, right? I'm back. Yes. So, let me put it right now. I want you to all know that when I said the earthquake, their energy, their magnitude is more measured on a moment magnitude. I want you to know to say this: replaced, replaced Richter scale. So the Richter scale has been replaced by the moment magnitude scale. Okay? So Richter scale used to be the one which measured the energy that came from an earthquake, but now it is measured by a moment magnitude scale. Thank you. Good question. Right. So let's move on and let's talk about it. So Sequence of earthquakes. Sequence of earthquakes. Okay, we want to talk about the sequence of earthquakes. The sequence of earthquakes. Then we'll see. We can go to where they are found. The distribution of both earthquakes and volcanoes, just where they are found. That one is a very small thing, okay? So earthquakes sequence. Let me say this before. Generally speaking, we'll talk about where they are found on planet Earth, but I want you to just know, generally speaking, earthquakes are found, or earthquakes can mostly occur at or near plate boundaries. At or near plate boundaries. Though you can get an earthquake anyway. You can get an earthquake in Botswana. You can get an earthquake anyway. But this is the key word. Mostly occur at or near plate boundaries. This is where earthquakes mostly happen. At or near plate boundaries. That is where earthquakes mostly happen. Okay? At or near plate boundaries. And I want you to say all plate boundaries. All plate boundaries. Okay? All plate boundaries, yes. All 4 types of plate boundaries. Okay? So if you want, you can say all 4 plate boundaries. What are the 4 plate boundaries? Constructive, destructive, collision plate boundary, and conservative. And conservative plate boundary. And I want you to say constructive is also called divergent. CD, destructive, is also called convergent. Destructive can't be divergent, okay? It's C and D. C. When it's constructive, it is divergent. When it is destructive, it is convergent. Starts with a C. So D, C, C, D, like that. Then conservative, this one, is called also a transform plate boundary. So we have constructive, or sometimes it can be called divergent. We have destructive, sometimes it can be called convergent. Then we have the conservative, which can also be called transform plate boundary. All plate boundaries have earthquakes, generally speaking. So we'll see where on planet Earth we get these things. That is where we'll talk about where earthquakes are found, okay? Right. Tend to be stronger at which the other word for destructive is destructive, and also collision, and also transform. So, and conservative or transform. Plate boundaries. This is because at these 3 types of plate boundaries. Plates are not separating. Then you can say here, earthquakes also tend to be weaker at constructive, in brackets you say divergent plate boundaries. And you write below that to say, this is mainly because the plates are moving apart at this plate boundary. This is mainly because the plates are moving apart. They're moving away from each other. So what is the sequence here? Skip 2 lines and say, the sequence of an earthquake is the same. The sequence or order of an earthquake is the same regardless of the boundary, at which the earthquake occurs. The sequence is the same regardless of the boundary at which the earthquake occurs. The sequence of the earthquake will be the same. Sequence of every earthquake. Sequence of every earthquake is as follows. Number 1, as the tectonic plates move, they get stuck. That is at every boundary. The sequence of every earthquake, which is at boundaries, okay? That's why most earthquakes happen at boundaries, is as follows. As the tectonic plates move, they get stuck. Number 2, pressure starts building. Pressure starts building up as the plates continue to try to move. Pressure starts building as the plates continue to try to move. So they get stuck, they try to move, pressure starts building. Eventually, the plates jolt free, manage to separate. Eventually, the tectonic plates, we'll see the tectonic plates, don't worry. We'll see those tectonic plates. And it will help you understand a lot. So that'll be the causes. We'll talk about it as the third thing, okay? The causes of earthquakes. So we'll talk about these tectonic plates so that you understand, okay? So that you understand. Definitely. So I'll give you a background of that. You need a background on that. So eventually the plates, write this now on the sequence, please. Eventually the plates jolt free and the pressure. This is not hard stuff, huh? Just to tell us what happens for an earthquake to occur. And the pressure, what happens? And the pressure is released. That was building up. That pressure is released as energy. Pressure is released as energy. So now you can go to number 4. Okay? The pressure is released as energy. Okay? The pressure is released as energy. And I want you to know that put number 4 to say the energy passes through the Earth's crust as waves, which is the earthquake. Which is the earthquake. Okay, well done. We'll talk about the sequence of events if an earthquake is caused, but just put this and say NB, human activity, e.g., drilling large balls into the crust, okay? Drilling into the crust. For whatever reason that mankind are doing it, or mining can also cause earthquakes. Can also cause earthquakes. Okay. Now, distribution of earthquakes and volcanoes. We've already talked about where earthquakes are found, but we'll just put it. Of earthquakes and volcanoes. Where are they found? Distribution of earthquakes and volcanoes. Where are they found? Start with volcano. Okay, volcano distribution. Most volcanoes occur at convergent, which is obviously destructive, or divergent, which is obviously constructive. Plate boundaries. Where do they most occur? At convergent, okay, and don't say or, and at divergent plate boundaries. That's where most volcanoes occur. Okay, so about 75% of active volcanoes are located around the Pacific Ring of Fire. Rim of Fire. The Pacific Ring of Fire. So let me put it in capital so that you can see it. These are 75% of active volcanoes. You can say some volcanoes also occur at hotspots. Also occur from hotspots away from plate boundaries. Away from plate boundaries. And these okay? Those volcanoes are just plumes of magma. Okay? Which escapes. Through the Earth's crust. I'll show you the Pacific Ring of Fire so that you can see it. It's like the same thing. It's a very similar area. Okay? Put B, earthquake distribution, then we'll go to causes and stuff. Earthquake distribution. We already know that they are found at plate boundaries, mostly. So let's talk about it like this. Write this now. On earthquakes. Just write to say, earthquakes occur at all types of boundaries. We talked about it. We're just repeating. For volcanoes, it has to be constructive or destructive plate boundaries. But here, they occur at all types of boundaries. About 90% of all earthquakes occur around the Pacific Ring of Fire. Which I want you to say, this is the Pacific Ring of Fire is just the rim okay? The rim of the Pacific Ocean. If you put this down, oh, the screen is now buried. Okay. Anyway, I think it's fine. I wanted you to put some things on things. I'll now teach you plate tectonics in the thing. But just before we do it, let's put background. Background to causes. Write with me this. Background to causes of, okay, Anthony shall send it. Background to causes of earthquakes and volcanoes. This is going to be a very, very important lesson. The background to the causes of earthquakes and volcanoes. Causes of earthquakes and volcanoes, this will be very small. Kind of talked about it already. This in the sequence to say what causes an earthquake. But and let's put this, then we talk about plate tectonic theory in our next lesson, okay? I want you to say this is going to be the earth, okay? If you cut the earth, so I want you to say layer 1, layer 2. You put it like this. And I want you to say layer 3, then layer 4. Okay? And I want you to say, when you write, this is the structure of the earth. So say here to say structure of the earth. Put structure of the earth here. It's going to be, and just write this statement to say the earth is composed of 4 main layers. The earth is composed of 4 main layers. Okay? 4 main layers. And these ones are 1. Should we start from the inside or from the outside? Layer 1 is on the outside, so we'll say crust. Okay? It's the layer 1 which is on the outside. This one is crust. And say here, the thickness varies. Okay? The thickness varies. We'll talk about them, the crust. Okay? But I want you to know that there are 2 types of crusts. I want you to know that there are 2 types of crust. Okay? A, oceanic crust. Okay? This one is thick. And I want you to say, in brackets, say 25 to 90. And this is kilometers. Okay? It is old and less dense. Oh, okay. We're starting with oceanic. Ooh, I made a mistake. I'm talking about oceanic is thin. I mean, is thin. I'm sorry. So cancel. This is 5 to 10 kilometers. This is oceanic. is thin, 5 to 10 kilometers. And it is heavier. The heavier, or in brackets say denser, than continental. Are we together? And it's entered the continental crust, but it is thin. B, on the other hand, continental crust. The land, oceanic crust, the water is heavier. Continental crust is thick, which is 25 to 90 kilometers. Okay? It is old, and then it is less dense. Less dense than oceanic crust. Okay? Less dense than the oceanic crust. It's lighter. Lighter. This one, heavier. It is thinner but heavier. Right. So now we'll talk about the other parts of the thing. It's made up of 4 main layers. Number 1 was this crust. Number 2 is going to be the mantle. Have you done it? Right? Mantle. That's the second layer. Now I want you to say, this layer, it's layer 2. This layer, right? About 2,900 kilometers thick. It is a semi okay? It is a semi, in brackets say, molten layer. Okay? Semi-molten layer. It is less dense. It is less dense. It is less dense than the outer core. All right, so we'll finish from here in our next lesson, okay? Or should I just finish? Let me just finish. Let's layer 4 is the crust. Okay? Then layer 2 is the mantle. Then we can go to layer 3 and layer 4. Layer 3 is obviously the outer core. So when you talk about the inner core and the outer core, because we're coming from the outside, this layer is about 2,100. Okay, kilometers thick. Okay, then it is. It is a semi-molten layer. It is a semi-molten layer. Have you written it? Okay. Temperatures are between and 5,500 degrees Celsius. Last one is inner layer. So here, write this, about 1,400 kilometers. Okay, about 1,400 kilometers in diameter. It is a solid layer. It is a solid layer that is dense. Are we together? Solid, dense layer is composed of solid dense layer is composed of, are you checking? Of iron and nickel. Then last thing, temperature is about 5,500. This is the last thing, 5,500 degrees Celsius. Then you'd be done. So if you draw, okay, I'll call you back just now. I'm coming just now. If you draw, what is this? Inner core. Next layer, outer core. Next layer, hello, thick as well. Mantle. Then crust. In crust, oceanic. What is oceanic? 5 to 10 kilometers. Okay, then continental crust is 25 to 90 kilometers. Then the mantle, I've given you the distances already. You've written them down. The mantle, 2,900 kilometers in thickness, right, in diameter. Then next, outer core, 2,100 kilometers. Inner core, 1,400 kilometers. So this is by far the thickest. And that's what you must just have. By the way, this is the outside here is the surface. This is as you go into the thing. This is the surface of the earth in green. And you're done. This is the surface. So now in the next thing, we'll start to talk about the crust, because you've seen the crust. And we'll talk about the tectonic plates. What is the tectonic plate? We'll explain